Okay, Matthias, please.
Yes, hello. Actually, I was not prepared saying something, but I just wanted to say, actually, I think I'm sorry that I cannot be in Rwanda. I would have loved to be there, and I hope I can do this later in the year or maybe next year, as soon as possible. So I wish you really a great conference.
Sorry, Matthias, please, can you hold on 1 minute?
Hmm?
Hold on 1 minute. We're getting speakers. No, but where's the other one? No, the smaller one. The circular one. Where's the circular one? Yeah. Because this one will take me time to connect. Okay, Matthias. Yeah, hello, Matthias. You can start now.
Okay. Yeah, I think I started already, but was that already transmitted, or should I simply start again?
Please start again. Thank you.
Okay. Yeah, I really like to welcome all of you. I see a good crowd being together. I hope that we will have a really good conference. I mean, we had really several very interesting talks over the last months. You should everyone who is there, I think, should really know that you can contact the speakers, even if I'm not there. So I'm really very sorry that I cannot be in Rwanda. But whenever you have a question later on, please reach out to us, to me, but also, of course, to the other speakers who were not able to come. I definitely hope that I will be able to come later this year at an independent visit. But at this point, I wish you all a lot of fun and really a lot of success with this great workshop. Thank you, and I'm happy to be part of it.
Thank you very much, Matthias. It's a pleasure to have you. Professor Jamako Rinianis is also here. Jamako, do you want to say a few words? Please. I don't know if my camera is okay.
It's okay, but it's a great pleasure to be here. So it's my second time here in Kigali and the school. So I enjoyed the last time very much, and I look forward to the exchanges that we will have. So don't hesitate to ask questions to me because I'm here, but also to the others. And so let's enjoy this conference. I think that indeed the talks are going to be very interesting. So let's take advantage of all that. It's a very nice setup of speakers, and I thank Omololu for organizing all the details about that. Thank you very much. Enjoy that.
Okay. Thank you. Yeah. So now I'm going to share my screen. Okay. Okay. So good morning, everybody. So I'm going to be the first speaker, and I'm going to give an introduction to Python. So I'm going to give an introduction to Python. Many of you know about our institute already, so I won't go into details about telling you about our institute. It's funded by the government of Rwanda, and it's set up by in collaboration with ICTP in Italy and University of Rwanda, and it's a Category 2 UNESCO institute. So I think that's as far as I will tell you. So now we are going to start with this. Okay. Sorry, can you all see my screen? Can you all see my?
Yes, we are seeing.
Okay.
Yes,
So these are the
yes,
top
we can
I'm
see
going to
it.
do introduction to Python. So many of you know how to install the IDLE already using Anaconda. So we are going to see. I won't discuss about that. So for you that are in Kigali, the software is already installed on the computers that you have. Okay. So the software, they're already there, and you can launch them and try to follow some of the things we are doing together. I'm just going to give you a brief overview because I have just 1 hour. And in this 1 hour, we go all the way to matplotlib, all these topics. We'll probably also start on files. Object-oriented programming, we won't start. I'll just tell you what it is. Later in the afternoon, we could do it, okay? Because we don't have all the time. Okay. So if you go on your computers that you have with you, we've already installed Anaconda 3, and with it comes the one we installed is actually Jupyter. Sorry, it's Python 3.8. So you can, if you like, you can type Jupyter. Let me see. Yeah. So at the command line, you could type Jupyter. Let me see. I want to get a command line.
If you can make sure that the robot is connected.
Oh, yeah.
Access to the Jupyter notebooks.
Okay, so for the computer, all you have to do, if you are seated at the computer, I think all the computers are on. The password is IFR, EAIFR. The username is IFR. So the password is EAIFR, and the username is EAIFR. If you're on the computer, if you're on the desktop, if you're on your laptop, you have to go to this place and download Anaconda. And then depending on whether you download the Linux version or the Windows version, then you just install it. The Linux version is very easy to install. I guess the Windows version is also very easy to install. The Mac version, I've not done it before.
It's very easy.
Okay, very easy to install. So please download it. If you need the executable for Windows, well, for any of them, I can talk with you after the class and then give you the executables because I downloaded some of them too. Okay, so the first thing we are going to talk about is just about variables. Can you all see what I have on the screen? Okay, so the first one we will talk about is how to create a program that's interactive, how to receive the data, how to do some processing. Yeah. So in this case, to receive data from the user, you use this command, this function called input. So in this first line, which has input, atomic number, and mass, when I execute it, it's going to write two things. It's going to write one thing. It's going to say atomic number and mass. It wants you to put in the atomic number and the mass of whatever element you want to work on. Okay, so this is the way you do it. If you want somebody to input the age and the height, you just put this input and atomic number and age and weight. Whatever you want the person to input, you put it there. Even if you don't put anything, if I leave this place blank, it will still ask for something. Okay, and then, but how would the user know what to put in? So that is why we put some text here so that you know what to put in. So with Jupyter, how do you execute a cell? Yes, you can do run, okay, but the other thing you can do is what? Shift enter, okay. So I'm going to do shift enter. My var is going to take into variables. And then I use a function, a method called split, to split the two things, okay? So it's going to split it into one, which is the atomic number, my Z, and another one, which is the mass, my mass. Okay, so remember the way to get data from the user is by using this input atomic number and mass, okay? This will take two things. It will return a string. The string, I'm going to split it based using the space in between them. If you want to have three numbers or three things, you can split it also based on three things, but this one we just split it, and it's going to use space as the delimiter between them. And then it's going to print my Z and my mass. When it takes those two things in, it's going to take them in as strings. So I'm going to shift enter, execute now. So it's asking me for atomic number and mass. So the atomic number, I'll put 2 for helium, and I'll put 4.0 for the mass. So this is for helium. I hit enter. So you see it printed the atomic number, which is Z, which is 2. The mass is printed 4.0. Then I also ask it what is the type of my Z and my mass. Strangely, you see that my Z is a string, so it is not a number, it's not an integer. My mass is also a string. So a string means they are just characters. Do you want me to make this bigger? Okay. So a string means they're just characters. So if you try to add them together, it's going to concatenate them. So if you do my Z plus my mass, or my Z times my Z plus my mass, it's just going to write 2 4.0 together with no space. Because whatever you read using the input is a string. Okay. So whatever you read using this input is a string. And now what you have to do is you convert the string to the objects that you want them to be. So these two that I've done, I've been able to combine them. So this input, I combine them into one. Input and split, I combine them into one. So I do it in one line now. I input this and then dot, I split it. So instead of 2 lines, where you first take the input as my var and then split it, you can put everything in one line, because this will return an object. And then the object, you can use it and call the method of the object. Okay. So now, so I can do this also. You do it, it gives you the same atomic number and mass. Atomic number is 2 for helium, and the mass is 4.0. Let's do 4.0125. I think this is the correct one. Okay, so it writes 2 for you for the atomic number, and 4.0125 is for the type. Okay. So what I do next is I'm going to convert it to an integer. So once you read it, you can convert Z to an integer by typing my Z is integer my Z. Okay. So this will convert your string to an integer. And then also the mass, I want to convert it to a float. It will convert the mass, which is a string, it will convert it to a float. So now if I execute this cell, I'm going to see that the types will change. So now I executed this cell. It's still 2 and 4.0125, but the type of my Z now is integer because I did a type casting. I converted it here in this line to an integer. And here I did a type casting. I converted it here to a float. Okay. Any questions so far? This is straightforward. So once you read from the screen, or is a string, even once you read files also, later on you see that files, it reads them as strings, and then you have to convert them to whatever type you want to use them. The next one we'll talk about is we'll talk about lists, tuples, and dictionaries because they occur a lot. So you can open your Jupyter and do the same thing, but also I will give you the Jupyter file. Actually, you can follow also. Maybe the better thing would have been to give you the file and then you can type it to yourself and do it yourself also. Yeah, it won't be easy for me to do it now. Okay, but you can just follow and then I'll give you this later on and we'll do it during the exercises in the afternoon. Okay, so here, first we create a list. We create an empty list, and this is the way to create an empty list. And then if you want to populate the list, you append. Okay. The thing about the list, which is different from say your Fortran or your C++, is that the list, the elements of the list don't have to be the same thing. So for instance, I append a string, helium, I append an integer 2, I append a float 4.0. Okay. And I can print all of them. Okay, so I do this and I can print my list and the length of my list. So you see that the length of my list will be 3 because I have 3 elements. And then my list, it will just print helium and then 2, which is this second one it appended, and 4.0. So this is how to create an empty list, and you can find the length, how many elements are in the list. So it's hard for you to do this in C or C++ or in Fortran. In Fortran, you declare the array to be integer or float, and then every element you have there has to be integer or float. In Python, you can use a list and create any kind of different objects within the same list. So what's the difference between a list and tuple? A tuple, okay, apart from the fact that you use curved braces, which is just aesthetics, the other thing is that a tuple, you cannot change a tuple, it's in place. So I created this tuple, which is Monday and Tuesday. If I try, there's no append function. Okay, if you try to append and add something to it, you cannot. So a tuple, you create it once and it's there forever. You cannot change it. It's a way also to be able to store some constants. Okay, so once I do this, Monday, Tuesday, you cannot delete Monday or Tuesday. Okay, you cannot add Wednesday. It's fixed. Okay, so that's the thing about my tuple. If I do this, it works. If I try to append it, I'll do this just now. You see the error that I'll get. Okay, so you see it gives me an error when I try to append to a tuple. It says tuple object has no attribute append. So you cannot append to it and you cannot change it. Okay. Now the next one we'll go to, so tuples, so list, tuples, and dictionaries. So if you want to access an element of a list, the general way to do it is to write, let me introduce something here. The general way to do it is to write something like my list. This will give you element 1 of the list. Okay, element 0 is the first one. Element, so it starts counting from 0. So element 0 is the first one. Element 2 is, sorry, element 0 is the first one. Element 1 is the second one, and on like that. So if I write my list 1, what do you think is going to write? So if you go up here, so my list is this, helium 2, 4.0. So if I write my list 1, what do you expect? Yeah, be bold. What do you expect? Yeah, it's going to give. It's going to write 2. Exactly. The other one, the other thing we introduced now is dictionaries, and with dictionaries is useful because instead of using indices like this, okay, you can use a key. Okay, so the way you create a dictionary is you put a key and then the value of the key. Okay, and then a key, the value of the key. The key does not have to be a string, it could be any object, and then you put the value of the string. Okay, so in this case, I created an object whose value 1 with 10.5, value 2 with Adam, and then my dictionary, I create a key, and then the value, a key and the value. So my element 1 is H, my element 2 is HE, if I scroll. And then I can print my dict. The way to access the element is not by saying element, my dict element 0. Okay, you have to put the name of the key. So this is very useful. We'll see later on why. I mean, not today. So you see, when I ask for it, it gives me the element. I mean, it gives me the entry whose key is my element 2. So in principle, you should not be able to ask for, if you try to, so who knows what will happen if you try to ask for element 2 of my dict. Actually, I think this is the one. Yeah, it doesn't. So you see there's an error because for the dictionary, you access it using the key. So there's no element 0, element 1, element 2 in the dictionary. Okay, all of these elements, they are not arranged. They're in any order, so you can ask for element 0, element 1, element 2, but you can ask for it by key. So I need to mute. Okay. So I apologize if this is very basic, but these are important things as we know, and then we'll use later on. Okay, so list tuples dictionaries, then you should have them down. The other one we have now, we'll talk about is decisions and loops. So, okay, so you use else if, so you use if, elif for else if, and then finally else. So I've read my mass, and then if the mass is greater than 4.0, it's going to print my mass is this. If the mass is less than 4.0, it's going to print my mass squared is this. Otherwise, it's going to print I am helium. Sorry, let me do one thing because I put 4.0125. So let's put my mass to be exactly is 4.0. Okay. So with okay, let's do it first without this. Okay. In this case, my mass is 4.0125. So if you run it, it says my mass is 4.0125 because you remembered from before. Okay. If I change my mass and make it 4, because 4.0125 is greater than 4.0. Okay. If I change my mass to 4.0, it's exactly 4.0. 4.0 is not greater than 4.0, so it won't go here. 4.0 is not less than 4.0, so it won't go here. And it will print exactly this, that I am helium. Okay, so it prints exactly this, that I am helium. You have to actually be careful about this because of floating point accuracy. Okay, so this is how to make decision. Use if else statements, and then you'll be able to make decision. It's similar in different programs also. Now, the other thing we'll talk about is if you want to make a loop, if you just want to print the numbers from 0 to 4, this will help you to do it. For I in range 5, it will print I from 0 to 5 because this range, what it does is, if you just put range 5, it's going to take everything from 0 up to, but not including 5. Okay? And then it's going to print it, and then it's going to print I squared. Okay? So this will just print this. So this is similar to your loops that you have in Fortran and everything. So let's execute this. So you see it's printed 0, and then 0 squared, 1 and 1 squared, 2 and 2 squared, on like that. Okay. The interesting thing is if you have a tuple and you want to print item by item in the tuple or in the list or in the dictionary, there are shortcuts that you can use. You don't have to know the elements that are in it. Basically, you use this syntax. So for anything in my tuple, so it's going to take it one by one, and then it's going to print it. Okay. So in my tuple that we had Monday and Tuesday. So this is going to print the first thing it sees in my tuple, which is Monday. The second thing it sees in my tuple, which is Tuesday. So this is going to print this. You see, I don't use any index. I don't say index 1, index 2, or anything like that. So you do this, and it's going to give you Monday and Tuesday. For dictionaries, you can do this similar thing. Okay. For dictionaries, what it does is each item will be the key. So it's going to take the keys, and then it's going to print the key, and then it's going to print my dict and replace item here with the key. So for each key in this thing, it will not give you the same result on different computers, okay? Because there's no order in dictionary. So it will take one that it wants, another one that it wants, another one that it wants, but it will print all of them this way. So let's do this. So key 1 was 10.5, key 2 is Adam, my element 1 is HE, my element 2 is helium. So it printed the key, and then it accessed the value by using this construct. Any questions so far? The other one we'll talk about is while loops. For while loops, you have to be careful because you can have an eternal loop in while, and then you keep waiting and waiting. So basically is this while this, okay? And then you tell it what to do while this is true. You notice here that I put J plus equals 1. This means J, increment J. So J is J plus 1. This is what this means. And then it's going to print, okay? This loop is going to end, okay? Because I thought carefully about it and make sure it ended, okay? If you put while J is greater than 5, actually it won't start. So you can think about this loop, but you have to be careful that you have something in it that will make it terminate. If you don't, it will just keep going on forever, or it may not start at all. So this one is going to print when j is 0. When it starts, j is 0, it's going to print 0 and 0 squared. Then it's going to increment j. And then it sees that j is now 1 and is less than 5. So it's going to go on again and print, do it again. Now j will be 2 after this line. And then it's going to see that, okay, j is 2 and it's still fine. It's going to increment it again and go on. And then when j is 5 is not less than 5, then it will not execute space anymore. So this is your loop. It does exactly this. 0, 1, 2, 3, 4, and defines the square. Okay. So this is pretty straightforward, and I think everybody knows this. Okay, there are other things that I'll give you to read up. You can break, meaning you can have a loop and you can let it break out of the loop, okay, whenever you want it to. So like that while loop, you can make it break out whenever you want it to break out, okay? And it will break out of the loop. You can use continue. What continue does is, when it gets to this point, instead of executing the rest of the loop, continuous means don't execute the rest, just go on and pick the next number. Okay? So continue, it won't go on, and it should just not finish executing the loop and go on to pick the next number. Try and accept is very important. You may want to do an operation which is forbidden. So if you don't want your program to crash, you still want it to continue, what you do is you try to do the operation that may be forbidden. And if it doesn't work, then it goes to the accept command, and then it does the accept. Okay. So I say you should read up on it because I know I have only 1 hour. You know, there was a time that was a handout that I had. It was Perl in 1 afternoon. I photocopied it, and when I had any problem, it was very helpful. I used it throughout the 3 years I was in Boston, just using it. It was probably 1 afternoon. So this one also is like Python in 1 morning. Okay. Although I cheat, I tell you now to read up all this stuff. Okay. I think after this, I'll spend some time writing something Python in 1 afternoon and just make something short that you can use for reference. Okay. So for function and modules, a function is exactly what mathematicians call a function. It may have some things that are different from exact mathematical precision, but basically what you want it to do is that you want it to give you some variables, and then you want it to return something or to do something. It doesn't always have to return something, okay? But it can just do something. So this is a simple way to define a function. So I define a function. So you use this def, okay? And then I define a function f1 of x. And all it does is it finds the square of the number and then it returns the number. Okay, so this is what it does. And then I can, so now my mass, you remember, is 4.0, and I can call my function f1 and call the function with this. It can be something more complicated than this. Usually you use a function when you have something more complicated that you want to do. And instead of having to do it in place, you just call the function, it does it. Imagine if I wanted to square this and find the sign and do different other things with it, you can just define everything in a function and you do this. So if I do this, it's going to print my mass, which in this case is 4.0, and it's going to print f1 of 4.0, which is 16. So let's see what happens. What?
You didn't define the function.
Oh, sorry. I forgot. I did not define the function. Oh, well, let me illustrate this for you. So if I read this, you see, it tells me name f1 is not defined. So please, this is very important. Don't just say, I ran the program, I had an error. No, tell me what error you had. You don't tell the doctor, I'm sick. He asks you questions. What? So it's very important. Don't just say, I ran it, it had error. Okay, please tell us, what error did you have? You can also take a look at the error. So it tells me name f1 is not defined. So like Gianmarco said, I did not execute that other line. One of the good things also is I found with errors is sometimes you can Google some errors. Okay, not this one. And other people, I mean, there are 8 billion people all over the world. Many of them would have had the same problems. So you can Google, and then many times word for word is there. You just and look at the solutions. Okay. So of course, let us know exactly what the error is. So I should execute this first. Thank you, Jamako. And now I use the function, I print. So you have exactly 4.0 and 16.0. Okay. One of the exercises we gave before is to write a Python code to check whether a number is prime or not. Okay. So please, you still work on it. You write a function so that if I give you a number like 12, it will tell you whether it's prime or not. If I give you a number like 13, it will tell you whether it's prime or not. Okay, so you should write a code like that. You will use all the constructs you've done before, if else, things like that. So it's good to do that. There are other things that you have for functions, which I'll leave for you to read up. For functions, you can use default parameters. Give an example here. Okay, you can but sometimes they call it with two variables, sometimes they call it with no variable. I was just confused. Like, how does this function know which variables? You know, when you don't have the same number of variables as the function. Like in this case, I called it with just one function. Okay, you'll see just now. So one way is you can have default variables. So in this case, for instance, I define the function f2 with two variables, x and y. But you see, I write y is equal to 6, so y has a default value. So if you don't put the value for the second one, it already takes the value for you. Okay, so I can call f2. Yes. Is it possible for us to have the new file? Yes, I will give you the file afterward. Actually, like I said, I should have just given you the file so that you'll be able to execute as I go. But yeah, so I'll give you this. Without the output, I'll give it to you. You'll be able to do it. So in this case, for instance, I can call f2 with one argument. I can call it with two arguments. Okay. So if you call it with only one argument, it takes the default argument. Okay, there are rules for it. You have to make sure that all the default ones are at the end of the list. Okay. So if you read it up, it will tell you more about it. So if I call this with f1, it's going to use 1 here for x, so it's 1 squared. But because I don't give you the second argument here, it's going to use 6. So this first one will give you 1 squared plus 6 squared, which is 37. This second one, because I supply a value, is going to give you 1 squared plus 3 squared, which will be 10. So let me not make the same mistake again. So I execute this, I define the function. You don't have to write your own function, you'll see later. Other people can write the function for you, and there are many functions that people have written for you, just for you. Okay. So I do print, and you see, whether you do f2 of 1 or f2 of 1, 3.0, it works. So you don't have to be confused as I was when I started with Python. There are other things you can do. Okay. In Python, there's something called modules, and modules are Python files that contain functions. All these functions, f1, f2, I can put them in a file and call it a module, and it will be a module file. The name of the file will end with .python, and so the way you do it is you import the module name. So the module file will contain the functions, and then you call the function in the module by module name dot the function. Call the function, say the function f, okay, by module name the function. This is one way to do it. Let's call it f100. So there's a reason why I'm calling it f100. So I call it f100. So you call it this way. The function f100 is in the module, it's in the file, so I can call it module name dot f100. Okay? You see, f100 is long to write. So the other thing you can do is you can, okay, you'll see this soon. The other thing you can do is the module name may be long to write, and then you can import it as a short name. You'll see that soon when we do NumPy. Another thing you can do is from the module name, you can import the function. Depending on what you do, Or you can import from the module name, you can import the function as a short name. So if you do this last one, for instance, then you can just call the function f in module name by f of something. You don't have to use something like this, module name dot f something. Okay, I will illustrate both of them just now. Ouch. Sorry, so I'll illustrate both of them just now. So there's a module called math, and like you expect, people have written a lot of functions in maths. Okay? So if you don't execute this module and you just try sine 0.2, this is going to give you an error, okay? Because Python does not know how to calculate sine. Sine is not defined. Okay? But sine is defined in this module called maths. Okay? So I can import math, and then I can do maths dot sine of 0.2. So let's do that. I import math, and I do math of sine 0.2. Still, this sine 0.2 is not defined. Okay? What is defined is math dot sine. So this still is not defined. Okay. Another thing, so let's look at what the other way I told you. The other way I told you is that you can say from module name, import the function. Okay. So I'm going to do that just now using another module. Another module is NumPy, numerical Python. Okay. Numerical Python also has sine, cosine, and many mathematical functions, and is more powerful than maths because it helps you to do something called vectorization, which I think we'll see later. So from NumPy, import sine. Okay. So I'm going to execute that. So remember, if you just execute this, it's going to tell you it's not defined. Okay. So, but if you do from NumPy import sine, I'll do this now. So it has imported the sine function from this NumPy module. And if I do sine 0.2 now, it's going to print sine 0.2. This sine 0.2 comes from the NumPy module, not from the math module. Okay. So I give you 3 exercises. Okay. One is how to know the module a function belongs to. So if I give you a function, you want to know this function, does it belong to the math module or to the NumPy module? Okay. So you should do an exercise. This is really searching online and see how to do it. If you have a module, how do I know all the functions in the module? Okay, you should be able to do this also. You just use, in this case, I'll tell you, just use dir. Dir will tell you, you import the module first, and you do dir on the module, and it will tell you all the functions that are in that module. Okay, so for instance, we've imported math module. No, we've not imported math module. We've imported NumPy, and then we can. So let's do this. So if I do dir math, it should give me an error because this is strange. Did we import? Oh, we imported math. Yeah. Okay, but if I do yeah, because I imported math already. So these are all the functions that I math. If I try to do this, ouch, sorry. This one gives me an error because I've not imported NumPy. NumPy has not been imported. Just from NumPy, I took something, but I didn't import NumPy. Math, I imported. So I import maths, okay, but for NumPy, I just imported something. Okay, so this will give you an error because NumPy is not yet defined. Okay, so now we'll talk about the NumPy module. It's one of the important modules. It makes it easier for us as humans to work with arrays, and it makes it easier or faster for the computer to work with our arrays. It does something called vectorization. So,
can I ask a question?
Yes, absolutely.
Yeah, please. When you import a module, how do you deactivate it such that, I mean, you don't want it to? Yeah. So how do you deactivate it?
Good question. If I import a module and I want to de-import it, I don't want to import it anymore.
Yeah.
I have no clue how to do it. I think my only way of how to do it is to restart your kernel. Yeah.
Okay.
That's the only way I know how to do it, to restart your kernel. Yeah.
Okay.
Yeah. This, yeah, interesting question, but yeah. Yeah, you have to what? You can delete the module. Are you sure? What? And oh yeah, rerun the cell. No, if you delete it and rerun the cell, it's still there. You have to restart the kernel. Yeah, this is the interesting thing because you know if you restart the kernel, all your variables that you find, they are gone, and you have to redo them again. Yeah, I think there should be a good way.
What if you comment the import command?
No, he's saying you imported it already, and then, for instance, for this sign, now let's say I was using the sign from math before, and I wanted to change to use the sign from NumPy. So the one from math is already imported. How do I unimport the other one? Okay. So if you comment it, it's still there.
Okay.
Rodrigue.
Okay.
Yeah. Include what? Oh, no. They're separate. Yeah. I've not looked inside the hood. NumPy may steal some functions from, I say steal, may borrow some functions from maths. I don't know. Well, in my experience, NumPy is more powerful than maths. So I think it may borrow some things from maths. Yeah, maybe. Okay. So if you want to add this list and this list, so I want to add 1 and 13, 3.2 and 15, 7.5 and 32.1, 8.9 and 12.0. You really cannot do it easily if you keep them as list 1, list 2. If you do list 1 plus list 2, it's just going to concatenate them. You're going to have a longer list. Okay. Do I do that here? Oh, okay. So if you do list 1 plus list 2, which I say do here, print list 1 plus list 2, it's going to give you a longer array which contains all in list 1 and all in list 2. It's not going to add element by element. If you want to add element by element, you have to write a loop. Okay. But with NumPy, you will see that you can just do it with something called vectorization. Okay. So this list 1 is a Python list. List 2 is a Python list. Now from list 1 and list 2, I create 2 arrays, array 1 and array 2, using, you see, here I import NumPy as NP. Okay, people say the reason is because NumPy is too long and NP is shorter. Okay, so why not N or N? But NP, okay, NumPy, NP is shorter. Okay, if you just import NumPy, then everywhere you have to type NumPy here, not NP. So importing as something makes it easier for you. Okay, so here I created a NumPy array, np.array, from the list. I do the same thing from the second list. Now I do array 1 plus array 2. This now is going to add element by element. Okay, I'm going to print. I do array 1 times 10.0. It's important that I said 10.0. It's going to multiply each element in array 1 by 10.0. Array 1 times array 2, it doesn't do a dot product. Okay, it does element by element multiplication. So it will multiply 1 by 13, 3.2 by 15, 7.5 by this by this. So I'm going to execute everything in one shot. Okay, so we'll see. So you see that the first one, array 1 plus array 2, just added this and this. 1 plus 13 is 14, 3.2 plus 15 is 18.2, 7.5 plus 31, 2.1 is this. Okay. The next one, it multiplied each element by 10. And then the last one, it did 13 times 1, 3.2 times 15, 7.5 times this, 8.9 times 12. And it returned this array to you. Okay. So this is very useful. It does the vectorization. If you keep them at list and you try to add element by element, like I said, you have to write it. This one, it just adds them like vectors. Okay. If you have the original, sorry, hold on. If you have the, don't forget your question. If you have the original list 1, which is the Python list, if you do list 1 plus list 2, you'll see what it will give you. If you do print list 1 times 10.0, this will be an error. You see, this is different from list 1 times 10. Okay. If you do list 1 times list 2, I don't even know what that will give. So I do this. The first one it does, list one plus list two. So you see, this is list one, and then it concatenated it with list two. So you have a longer list. This one, list one times 10.0, it tries to do it. It doesn't know what you're trying to do. So it tells you, can't multiply sequence by non-integer of type float. Okay. If you change it to list 10, it's going to just, if I change it to 10.0, here, if I change this to 10.0, it's going to run. And so it's created list one 10 times. Okay. Because it's an, if you put an integer. But then it tries to do list one times list two. It has no clue what to do. Okay. Can multiply sequence by non-integer of type list. Okay.
What about if this one has alpha influence number of
Oh, yeah. Okay, so if list one and array one and array two, so I created array one and array two. Let's say they don't have the same number of elements. So it will be impossible to do. It's kind of like adding a scalar to a vector. Okay, I know my students write it all the time, right? But you can't, it will not be possible to do that. Actually, no, I take it back. It depends. For instance, yeah, it depends. So if I do array 1 plus 1.0, it will add 1.0 to every element of the array. You can think that 1.0 is a scalar, okay? But it's going to add 1.0 to every element of the array, okay? But if you try to do array 1 plus array 2, they don't have the same size. They will complain and tell you they don't have the same size. If you want to try to multiply, to complain and tell you they don't have the same size. Yes.
Now you mentioned that Numpy is just for medical.
Yes.
Then when you want to do maybe a string.
Yeah. Good question. Then you can use Numpy for that. So let's try. I think I created a list before. Yeah, let's look at my list. So her question is, what if the list contains alphanumeric things? The short answer is that you won't be able to do that. So let's let's print my list. I think it's my list one, right? No, it's my list. Okay, so my list is this. Can you convert it to a let's try to make it into an MP array. I don't know, it still works. But I don't know what will happen if you try to. No, because it took all of them as strings. Okay, it took all of them as strings. So you can see they're all strings. So you converted all of them to strings. Okay. And then it will be hard to know what happens if you add two of them together. Like if I do this, let's see. Yeah, it gives an error. Okay. Because then it doesn't know how to multiply a string by 2.0. Okay.
So there's no library that can invoke that.
No, not yet. Unless maybe some.
Does it need to multiply a string by 2?
No, maybe it's something that's intelligent that knows that this is a string, I should double it, and this is floats, this is a string, I should write it twice, and this is a float, I should multiply it by 2. Yeah. Actually, you know what? You can create a class that does exactly that. You can create your own data type with its own method that will do that. Recognize which ones are floats, which ones are string, and do exactly that. Yeah. But by default, I don't think we have one yet. Okay. You can do slicing, which many of you know how to do. So I can print array 0, array 1, from 0 up to but not including 2. List 1 also I can print. from 0 up to but not including 2. So you should read up a lot of things about slicing. We won't go into details, but you should read them up. I'll ask some questions later on. Okay, now we're going to talk about Pandas module. The reason we talk about Pandas module is because we use it a lot in machine learning and data science. Okay. It's an open source library. So it's built upon NumPy, and it provides 2 new structures. One is series, the other is data frames. Okay, we'll talk briefly about both of them. Okay, so like always, is a module. So you import pandas as PD. Almost everybody does it, like imports pandas as PD. Nobody imports pandas as PS. Okay. Everybody does import pandas as PD. To the point that after a while you think this is PD is another module on its own. No, it's just is a name, but pandas is the main thing. So array 1 I already have, okay, and I'm going to create a series from array 1 by using this pd.series array 1. So series is a method in pandas. Okay, so this will create a series. You can also create a series from the list 1, no problem, you can do that. And then I'm going to print. This print //n prints 2 lines. Okay. Then I'm going to print list 1 and I'm going to print this series. Okay. When you do that, you will see that when you have a series, what it does is it adds a label to your array. Okay. So you see that it adds a label to your array. Instead of adding a label 0, 1, 2 to the array, you can choose to add a different label to your array. So array 1, the length is 4. So instead of having 0, 1, 2 as a label, I want A, B, C, D as a label, then I'll print it. So let's execute this, I'll tell you everything. Okay, so I executed it. Okay. So the array is 1, 3.2, 7.5, 8.9. And then the series I first created from the array is this. So 1.0, it made it element 0. 3.2, it labeled it 1. 7.5, it labeled it 2. 8.9, it labeled it 3. Okay. If you use list also, it works the same. Whether you use NumPy array or list, it works the same. Okay. Now, the other case is I put some indices that I want it to label it as. So instead of labeling this as 0, 1, 2, I want it to label it as A, B, C, D. Okay. That's why I have this index, A, B, C, D. So it labels it exactly as I want it to do. Okay. Yes. NumPy and pandas. Okay, it's built upon it. If you do NumPy, it doesn't the series. Okay, if you just do NumPy, yes, it's
about pandas as an exception. It's a certain array table, and you have columns, you have lines.
Yeah.
Is a series of numerical libraries, routines that you can use, functions like the sign that was shown.
Yeah. Yeah. But when you create an array with NumPy, you can index it, yeah, but put it this, it doesn't put a label on it if you want. Okay. So in this case, yes, it puts a label and you can put an explicit label on it, like in this case. This one I labeled it A, this one I labeled it B. Okay. With NumPy, it will, well, we say index. It will index this as 0, 1, and 2.
This gives us outputs in form of paper.
Yes, so that was it.
Nice format.
Yeah. Then apart from creating a series, you can create a data frame, and this is what we'll use a lot of the time. So this that I'm showing you, this one and this is just for pedagogy. You hardly do this. Okay. So you can create a data frame from a list. So I created a 2D list, and then the 2D list, I now create a data frame 1 from the list. So this is how you do it. You do pandas.dataFrame, you call the method, and you put my list there, and it's going to create a data frame from the list. So you can create series, you can create data frames. So let's see this. So this is what Professor Gianmarco was saying. It creates like an Excel sheet. So it creates columns and rows. So this is column 0, column 1, column 2, and this is row 1, row 2. Or if you like, row 0 and row 1. Okay. So ABC is the first list, and the second one is 0.5, 0.2. We put it there. So you see, it created a table for me, okay, like you have in. Yes, in Pandas. Yeah. And data frame is the one you use most of. If you like, you can also, okay, believe me, you will hardly do this. Okay, you can create a data frame from dictionary of list. So I have a dictionary where for an atom, I have the energies. Actually, for 2 atoms, okay, I have their energies at different separations. Okay, so I have an energy 0.5, 0.6, and 0.7. I also have their forces at the same separation, 0.9, 0.3, 0.1. I can create a data frame that will have all this information. So I do this. So it has the energies and the forces. For position 0, the energy is 0.5, the force is 0.9. For position 1, the energy is 0.6, the force is 0.3. For position 2, the energy is 0.7, the force is 0.1. Okay. You hardly do it. What you do most often is that you read in a pandas file, sorry, a CSV file. CSV means comma separated variables. Okay. There's also one that I saw recently, TSV, tab separated variables. Okay. So you use, so there's a read CSV method in pandas. So here I already have this file, pandas.demos.csv, on my disk. Many of you have seen this before already. Then I'm going to read it. I'm going to read it into a data frame called our data. So I'm just going to do that. I read it. So you see, I read it, it seems nothing happened. But once you don't have an error, it already read something. Then I can look at the top 5 of what I have of the data, our data data frame. So how exactly this? So it has, so this is the top 5 lines. It has the module ID. It's for some teaching positions, for some teaching school. So or teaching class. It has the module ID, CS101, 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 and then CS102. The instructor, the name of the instructor, the name of the TA, teaching assistant, the enrollment, how many students are there, the rating, there's a rating for each class. So it has this, okay. So for instance, instructor Aaron has a higher rating than instructor Calvin, or the class of instructor Aaron has a higher rating than the one for instructor Calvin. So this is the data that's contained in it. Sorry, this is part of the data that's contained in it. It doesn't show you all the data. If you just do this, it shows you the top 5 ones. If you want it to just show the top 3, of course, you can put a 3 here. If you want it to show you the top 6, you can put 6. So if I do 3 here, it's just going to show me the top 3. Okay. You can change the labels of rows and columns. I give you this as an exercise. So you can take the data frame and use the rename method. So what I do is the column that has TA, I want, instead of TA at the top, I want it to change it to teaching assistant. And then the index, instead of 0 here, I want it to have row 0. You can go ahead, instead of 1 here, row 1, instead of 2, row 2. And then teaching assistant, instead of TA, instead of rating, you could put R. You could change different things. So you could do this, and this will change it, because you can do something and say, okay, I don't want this name anymore. So you can change it. So I do this, it has changed it. If I do a head, you see that it has changed it. So you can see that now I have teaching assistant here instead of TA. And here I have row 0 instead of 0. So the index I changed, the column I changed also. The other thing that you use a lot for machine learning is you have to select the data from a data frame. So you can do that using a list of labels. So I have this, our data, and I want to select the column that says module ID and the column that says instructor. Okay. So remember this construct. You need to put in a 2D array. Okay. and in our data. So I create a new data frame called C, and I put this. This is going to give me only the column that has module ID and the column that has instructor, and then I head it to see what is in it. So I do that. You see, all the other columns are not showing. So C does not contain all the other columns. It contains all the rows, but not all the other columns. Our data is still intact. I did not change it, it's still intact. So this creates a new data frame. Okay. Another thing you can do is you can use something called masking. So I'll explain masking slowly. And then once I explain masking slowly, we will stop, and then Professor Alessandro Lyle, I think he'll be online, and then he'll teach us about unsupervised machine learning. Okay. So the way you use a mask is first, you create an array. What I've done in this array is I've taken our data and I've taken module ID of our data, and I look for all the places that have CS101. So equals means to do a comparison. So if you take our data, if you take this column that says module ID, and if you compare it with CS101, okay, the string CS101 inside it. Okay. If the module ID contains CS101, it will write true. If it does not, it will write false. Okay, and then you can print the array. So I'm going to do that just now. Okay. So if you look at the original array, you'll see that it has CS101, CS101, CS101. So the first three are true. Then CS102, CS102, those are false. Those will give you false. So if you do this, then you see it gives you true, true, true. And then all the rest are CS102, CS102. No other CS101 there. So it gives you false. Okay. So this is this array. The next thing we'll do is we now use this mask to create a new data. So what this does is everywhere it sees true, it will use that to create a new, it will use that to create a new data frame, X4. So this data frame, because there are only 3 truths, we have exactly 3 rows. So I'm going to do that. So you see, it created this one, CS101, CS101, CS101. Okay. You can do everything in one shot. Instead of first creating the array, okay, this is the array, and then putting that array in our data like I've done. So you see I created the array, I put that in this. You can create the same thing in one shot, which is what I've done here. Okay. So it does the same thing, but it does it in one shot. Okay. So I think it's time to pause. We'll go on to this ones later on. Because later on you will need to be able to select entries in the array and different things like that. So thank you very much. I'll check now if Professor, I didn't see your, oh yeah, how to label, so I think you've already seen. Professor Alejandro Lyle is online now.
Yes, I'm online.
So please give me a minute. So let me try to do something. I don't know if this will work.